Okay, today I want to show you how you can build such a module within Vivado with VHDL, and we also want to test this module here within a test bench. So we will at first build this model here, connect this AND and OR block with a signal, and then synthesize the input signals ABC within the test bench and read the output D and analyze the function within the test bench. Okay, for this we can start with creating a project here in Vivado. Let's keep it simple. We do not have to choose a part here because we do not bring our code or also our hardware disk encryption on an FPGA at this video. Now we can go to the settings because we missed it in the start settings. We can change the language to VHDL in the general settings, and also, but not necessarily, in the simulation. Then we press this plus for creating a design source, which is our VHDL code. Let's call it mod 1 for module 1. Now we can press finish, and now Vivado is asking me for input and output definition. We can skip it and make it later, or we just use this chance for defining our in and output with this, which are A, B, C and D, where D is an output. We can also, but which is not necessary here, define a bus. And just to showing you, we can do it here, but delete it. Now Vivado is updating, creating the file here in the design sources and also in the simulation. Let's go to the design source, and we can see here that we have the input and output definitions of the module, which is here the input. So this is a module, and we have one output D and 3 inputs A, B, C. Now let's change A to a normal standard logic, which means that the possible values are only 1 or 0, or true and false. Now let's create the signal X, which connect the A and the OR, which we can do by pressing signal X1, which has the type standard logic. That's it. Now we have defined the signal here, and now we can go between begin and end, where we can describe our hardware. Now let's start with X1 is A and B, and now connecting the OR gate, which is B, to the output is X1 or C. Now we are done with this step here. Now I want to do an unnecessary step for such an easy module, but which is very helpful when we have larger designs where we concatenate more than one module, which is a block design. Let's go and create a block design. Now we have the block design here, and we can use our source module 1 and now we have this defined module 1, where the behavior is described within our hardware description. Now we have another block, because it's a block design, and we want to define in and output, which we can do by pressing right click on this port and say make external, or Control and T. So make everything external, and for simplification let's call it A. And now we have our block design and want to test it, but now we have just a block design, no hardware description of our block design. To do so, we can press right click on this block design and say create HDL wrapper, and make sure that you pressed let Vivado manage wrapper and auto update, because when you do some changes here and save it, the changes will be also changed in the HDL code, otherwise it is not the case. The next step is to create the test bench. So when we look in our plan, we want to generate A, B, C within our test bench and analyze the output to make sure that our module is functioning correctly. For this, we press the plus again. Now we want to create a simulation source, create this file, call it mod1 underscore td for test bench, and now we can say finish. We do not define input and outputs, because when you look at the test bench here, we do not have input and outputs. And now it is generating this test bench here in the simulation. Now you can see that we do not have input and output as wanted. At first we have to declarize our design 1 wrapper, which is our block design, with the module within. Now we can look in this block design, it is just VHDL code, and we can copy this part here and now we can change entity to component, and also because of the language structure we can have to say and component. Okay, now this our block design is declarized in our test bench, and now we have to define our signals, because A, B, C, D are just the inputs, and we also want to have some signals which can synthesize some inputs. So let's start with first signal A, B, C, D, then we say it is standard logic, and now A, B, C, D are designed here. Okay, now we want to connect the component with our design. So we have component 1, which is design 1 wrapper, and we want to connect this with port map and say A is connected to the signal A, B is connected to the signal B, and now we have connected our block design. The VHDL has the behavior that everything which is defined here is executed parallel, which is what we want. But now we want to have a behavior which is successively testing our module with different input signals. So Let's start with a process which is doing exactly this. So process begin and end process, which is defining our process. Normally the process can do a little bit more, but now we are neglecting it because this is totally sufficient for our test bench. So now we can say A is equal 0. Okay, now we have the inputs and outputs defined, and we can simulate it by pressing just here run behavior simulation, and it's a good practice to do a lot of simulation before you test it on the hardware, because the generation of the bit stream which is executed on the FPGA take a long time, much more longer than a simulation. So be sure before you generate a bit stream that your code is, or your hardware description is running correctly within the simulation. Press simulation and run behavior simulation. You got this kind of window here. Let's look what's happened here. So at first we have a little bit of initialization where everything is 0. Then we changed A and B to 1, C is 0, and the output is also 1 as expected. Then we have a little bit of 0, and then we have C as 1, which is because of the OR connection. The D is also 1, and yeah, that's it. And we can see everything is working. We can also do go here inside the tree and go to our within our module, and can also observe x1 by taking it here in the window. And now we can see no data are available. This is because the simulation did not save the data while running. Now we can also run a few seconds here, and we can see the data are generated. It is because we never ended the simulation and it will repeat it, but we can also say, okay, we want to rerun the simulation and the whole simulation, and now x1 is observed. And we can see here when A and B is 1, x1 is also 1, but it is not 1 when C1 is 1. And yeah, so everything is functioning as expected for the tested cases, and now we are ready for more.